You ever been deep in a chat with an AI? Maybe you're 10 messages in, you ask a follow-up question, and boom, it knows exactly what you're talking about. It feels like some kind of mind-reading magic, right? Well, it's not magic. It's actually a pretty wild story of raw computing power meeting some incredibly clever shortcuts. So, let's pull back the curtain and see how it really works.
This is the big question, the one we're going to tear apart today. And it's not really about memory in the way you and I remember things. It's about the fundamental design of modern AIs, these things called transformers, and the brilliant engineering hacks that keep them from, well, grinding to a halt.
All right, here's our roadmap. We're going to start with the core problem of AI memory. Then we'll look at how an AI even begins to understand words. After that, we'll uncover the huge bottleneck that nearly stops the whole show. And then, the fun part. We'll reveal the genius trick engineers use to solve it all, and what that means for the future. Let's get into it.
So first up, the AI memory problem. You see, when we say an AI remembers, we're actually talking about a very specific, very technical limitation. It's all about how much information it can physically look at in a single moment. And this isn't just some software bug, it's a hard limit baked into the hardware.
That limit has a name, the context window. Just think of it like the AI's short-term memory. It's a bubble, and only the words that fit inside that bubble can be considered. If your conversation gets too long and spills outside the window, the AI literally forgets the beginning. Poof, it's gone. As far as the AI is concerned, those first messages never even existed.
And this is where things get crazy. Just look at the progress here. A few years back, GPT-3's 2,000 token window was state-of-the-art. Now, models like Claude 3 are rocking 200,000 tokens. To put that in perspective, that's enough to fit the entire novel The Great Gatsby in its memory all at once. This absolute explosion in capacity is what we're here to figure out.
Okay, but why is this such a unique problem for the AIs we use today? Well, older models, called RNNs, worked kind of like us. They read text one word at a time in order. The problem was they had a terrible memory for things that happened way at the beginning. But today's models, transformers, are different. They don't read one by one. They gulp down the entire text all at once, in parallel. This gives them a superpower for spotting connections, but it also creates a monster of a computational problem. So, let's back up for a second. Before an AI can remember anything, it has to be able to read. And for an AI, reading isn't about understanding definitions. It's about turning our language into pure, cold math.
And that happens in 3 key steps. First, tokenization chops our sentences into little pieces. Then, embedding turns each of those pieces into a long list of numbers, a vector, that captures its vibe, its meaning. So the vectors for king and queen would be mathematically pretty close. But here's the catch. At this point, a sentence like, "The cat chased the dog," looks exactly the same as "the dog chased the cat." The meaning is all scrambled. And that's where the third, absolutely critical step comes in.
And this quote just nails it. Positional encoding is the fix. It adds another set of numbers to each word's vector that says, hey, your word number 1, your word number 2, and so on. It's literally like giving every single word its own GPS coordinate in the sentence. Without this, the AI would just see a jumbled bag of words, and grammar would be totally meaningless.
Okay, so the AI can read. Now we get to the real heart of the problem. That superpower I mentioned, the ability for a transformer to look at every single word at the same time, that's called the self-attention mechanism. It's what makes these models so smart, but it comes at an absolutely insane cost.
And here's the key thing you need to understand. The amount of work the AI has to do doesn't just grow in a straight line as the conversation gets longer. No, it grows quadratically. What does that mean? It means if you double the length of the text, you don't double the work, you quadruple it. If you make it 10 times longer, it's 100 times more work. It gets out of hand fast.
This grid of fire gives you a perfect picture of that explosion. To figure out what the 5th word means, the AI has to compare it to the 1st, the 2nd, the 3rd, and the 4th. To figure out the 10th word, it has to compare it to all 9 words before it. You see the pattern? Every single new word has to be compared with every single word that came before it. This is that computational explosion in action.
So, this quadratic scaling thing was a huge wall. It really seemed like having super long, coherent conversations with AI was just going to be impossible because of the sheer cost. So, how did we get around it? Well, not with more power, but with a beautifully simple and elegant trick.
The solution is something called the KV cache. Now, don't let the name scare you. Inside that attention mechanism, the AI creates these special things called keys and values for each word. You can think of the key like a label on a folder, and the value is what's actually inside the folder. The KV cache is basically a cheat sheet. It saves all those folders and labels it's already made for the words it's seen.
See, before this trick, every time you added a new word, the AI had to go back to the very beginning and recalculate everything for the entire conversation from scratch. It was unbelievably wasteful. Imagine having to reread an entire book from page 1 every time you wanted to read a new sentence. That's what it was like.
But with caching, this is where the magic happens. The AI just reuses all the previous key and value calculations it has tucked away in its cache. It only has to do the heavy lifting for the brand new word and how it relates to all the old ones. And just like that, the game is completely changed.
And this is the perfect way to see it. On the left, without the cache, every new word sets the whole thing on fire with computation. It's all hot. But on the right, with the cache, the entire past conversation is frozen. It's stored, it's ready, it's efficient. Only that one new layer at the bottom is hot and needs to be actively processed. This is the efficiency gain we're talking about, and it's massive.
The KV cache was a total breakthrough, for sure. But you know how it is, it's not the end of the story. Researchers are already building on top of this idea with even crazier techniques, pushing AI memory towards something that feels, well, basically infinite.
And here are just a few of them. You've got things like sparse attention, which is like teaching the AI how to skim and only focus on the most important words. Then there's stuff like ring attention, which is a wild idea where you spread the AI's memory load across a whole bunch of processors, letting them work together to handle ridiculously long conversations.
And if you want to see the result, just look at this chart. Look what something like ring attention does. The standard methods, they top out down here in the tens or hundreds of thousands of tokens. But ring attention, it just goes to the moon. We are talking about context windows of over 10 million tokens. That's not a book, that's a library. All processed in a single go.
Okay, so all this tech is fascinating, right? But what does it actually mean for us? Why should we care about all this effort to expand an AI's memory? Well, the real-world impact is going to be huge.
I mean, think about it. With a massive context window, an AI can read an entire company's financial history and spot trends you'd miss. It could act as a writing partner that remembers every single character and plot point from chapter 1 of a novel you're writing. It could be a personal tutor that remembers every single question you've ever struggled with. The AI stops being a tool for quick, simple tasks and becomes a true partner, one with a deep, persistent memory of your entire project, your entire world.
And that, really, is the final question we're left with. The problem of memory, this huge bottleneck, is being solved right now. We're right on the edge of having AIs that can remember pretty much everything we tell them, across huge projects and long stretches of time. So the question isn't about the AI's limits anymore. It's about ours. What will we even ask a partner that never, ever forgets?